Picture this, a quiet tremor, too faint for us to feel, ripples through the Earth's core, thousands of miles beneath our feet. It's not the kind of earthquake that rattles windows or sends people running. No, this is something stranger, something deeper. A seismic anomaly that's got scientists around the world sitting up, squinting at their data, and wondering what the hell is going on down there. Just a few months ago, seismometers across the globe picked up a signal unlike anything we've seen before. It wasn't tied to a fault line or a tectonic plate grinding against its neighbor. It was a low, persistent hum, a whisper from the Earth's depths, hinting at a buildup of pressure so intense it could rewrite what we think we know about our planet's inner workings. This isn't your run-of-the-mill geological hiccup. Seismic anomalies are like cryptic messages from the Earth itself, hard to decode, harder to predict. They don't always mean disaster, but they always mean something's up. And this one? It's got researchers buzzing because it's not just a blip on a screen. It's evidence of something massive, something that could be tied to the planet's most explosive systems, like supervolcanoes. Yeah, I'm talking about places like Yellowstone, where the Earth's power lies dormant, waiting for a reason to wake up. So, let's dive into this mystery, unpack what we know, and figure out why this deep Earth pressure is making everyone a little nervous. Okay, let's break it down. A seismic anomaly is anything that shows up on a seismograph that doesn't fit the usual patterns of earthquakes, tectonic shifts, or volcanic activity. Think of it like the Earth's heartbeat going off rhythm. Normally, seismic waves follow predictable paths. P waves, S waves, surface waves, all tied to things like plate tectonics or magma moving around. But anomalies, they're the wild cards. They might be caused by anything from fluid movement in the Earth's mantle to sudden shifts in pressure deep underground. The problem is, they're tough to pin down. It is like trying to diagnose a patient who's speaking a language you don't understand. This particular anomaly, first detected in late 2024, showed up as a series of low-frequency vibrations originating from depths that make most earthquakes look like surface scratches. We're talking 100 to 200 miles down in the Earth's upper mantle, where pressures are so intense they'd crush you into dust. These vibrations weren't tied to any known fault lines, and they didn't match the signatures of typical volcanic activity. What they did show was a steady increase in pressure, like the Earth's core is flexing its muscles, building up to something big. Scientists are still scrambling to figure out what's driving it, but the data is clear. Something's stirring down there, and it's not business as usual. Now, here's where things get spicy. This anomaly isn't happening in some random corner of the planet. It's been detected in regions uncomfortably close to supervolcanic systems, and Yellowstone's name keeps coming up in hushed conversations among geologists. If you've ever heard of Yellowstone, you probably know it's not just a pretty park with geysers and grizzly bears. It's a supervolcano, sitting on a massive magma chamber that, if it ever decided to blow, could make every disaster movie look like a warm-up act. The last time Yellowstone erupted about 640,000 years ago, it blanketed half of North America in ash and changed the global climate for years. So why does this anomaly have people eyeing Yellowstone? Because the data suggests the pressure buildup is happening in the mantle beneath regions like the Yellowstone hotspot. Hotspots are places where plumes of molten rock rise from deep within the Earth, feeding volcanic systems. If the pressure down there is increasing, it could mean more magma is moving, or that the mantle is undergoing some kind of structural shift. Either way, it's like hearing creaks in the foundation of a house. You don't know if it's settling or about to collapse, but you're not going to ignore it. Let's be clear. Nobody's saying Yellowstone's about to erupt tomorrow. Supervolcanoes work on geological timescales, which means soon could be thousands of years from now. But even small changes in pressure can have big effects. More magma movement could lead to increased geyser activity, ground deformation, or even small earthquakes, none of which are great news for the millions of people living in the region. And Yellowstone's not the only supervolcano on the radar. Similar anomalies have been detected near other hotspots, like the Long Valley caldera in California and Toba in Indonesia. If this pressure buildup is part of a global pattern, we're looking at a phenomenon that could reshape our understanding of how the Earth's interior works. Here's where things get murky. The Earth's mantle is a strange alien world, hotter than a blast furnace, under pressures so extreme they turn rock into a sluggish, flowing goo. Scientists have a few theories about what's behind this anomaly. One possibility is that it's tied to mantle convection, the slow churn of molten rock that drives plate tectonics. If something's disrupting that flow, like a change in temperature or composition, it could create pockets of intense pressure. Another idea is that fluids, like water or molten rock, are migrating through the mantle, squeezing into spaces they don't belong and ramping up the tension. Then there was the wild card theory. Could this be linked to changes in the Earth's core? The outer core, a swirling mass of liquid iron and nickel, generates our planet's magnetic field. If something's shifting down there, say a change in the core's rotation or heat flow, it could send ripples upward, messing with the mantle and creating these weird seismic signals. This is still speculative, but the data's weird enough that even far-out ideas are on the table. What's frustrating is that we can't just drill down and take a look. The deepest hole we've ever made, the Kola Super Deep Borehole, only got to about 7.5 miles, barely a scratch compared to the 1,800 miles to the Earth's core. So we rely on indirect tools, seismometers, satellite measurements of ground deformation, and computer models that try to simulate what's happening down there. The problem is, the deeper you go, the less certain the models get. It's like trying to map a city by listening to its echoes. So, why should you care about some deep Earth pressure nobody can see? Because the Earth's interior isn't as disconnected from our lives as you might think. Changes in the mantle can trigger surface events, earthquakes, volcanic eruptions, even shifts in the planet's crust that mess with everything from agriculture to infrastructure. If this anomaly is a sign of bigger changes, it could mean more frequent or intense geological activity in the coming decades. And when you're talking about systems like Yellowstone, even a small uptick in activity can have massive ripple effects. Take Yellowstone as an example. Even without a full-blown eruption, increased pressure could lead to more hydrothermal explosions. Think geysers on steroids, blasting steam and rock into the air. These events can close roads, disrupt tourism, and pose real dangers to nearby communities. And if the anomaly is part of a global trend, we could see similar effects in other volcanic regions. The 2010 Eyjafjallajökull eruption in Iceland grounded flights across Europe for weeks. Imagine that on a larger scale. Beyond the immediate risks, this anomaly is a reminder of how little we know about the planet we call home. We've mapped the surface, explored the oceans, and sent probes to Mars. But the Earth's interior is still a frontier. Every anomaly like this is a chance to learn, to peel back another layer of the mystery. But it is also a humbling reminder that the Earth doesn't care about our schedules or our cities. It's a living, breathing system, and it's always got a few surprises up its sleeve. Scientists are doubling down on this anomaly, poring over data from global seismic networks and running simulations to test their theories. The United States Geological Survey, USGS, has already increased monitoring around Yellowstone, deploying more seismometers and GPS stations to track ground movement. Similar efforts are underway at other hotspots, with international teams sharing data to piece together the bigger picture. If this pressure buildup is part of a global pattern, we might be on the cusp of a new understanding of how the Earth's mantle and core interact. For now, there's no need to panic. The Earth is always moving, always changing, and most of these changes happen too slowly to affect us in our lifetimes. But this anomaly is a wake-up call, a reminder that our planet is more dynamic than we give it credit for. It's like hearing a distant rumble and realizing the storm might be closer than you thought. So, keep an eye on the news. Maybe take a moment to appreciate the ground beneath your feet. And know that deep below, the Earth is whispering secrets we're only beginning to understand.